Hey guys, what's going on? Nick here and welcome back to the channel. In today's video, we're going to be going through the present value of a single cash flow, or some people might say the present value of a lump sum, amount, or investment. Now I just want to let you know that this is now the third video of a time value of money series that I put together for you guys. And I've got a link to the place down below in the description and up above in the card. Now with that out of the way, let's jump right into it. So what is meant by present value of a single cash flow? What it is, it's the current value today on a cash flow that is going to be received at some point in the future. Now investors use present value calculations all the time, and what they're trying to do is work out how much they need to invest today to achieve their specific rate of return on an amount that they're going to receive in the future. Now, if you came from our previous video on future value of a single cash flow, which I've just linked up above, you already understand that by applying a growth rate or a required rate of return to today's present value will then become tomorrow's future value. Now, with present value calculations, it allows us to know or assume tomorrow's future value and discount it back in time, back to today's present value. Now, working out present value calculations is very simple, but before we get into the formula and showing you how to do it exactly, I just want to explain to you the relationship between present value and future values, and then just go through a little bit of terminology. So just looking at this timeline up above, assuming there's a 10% interest rate and a future value, a cash payment that we're set to receive in 1 year of $110. If we wanted to work out our present value today of this asset, and we're going to be using a 10% discount rate, all we would simply do is divide our future value by 1.1. So in a sense, what we're doing there, we're discounting our future value back by 10% to determine our present value today. Now, just to let you know, a discount rate is the same thing as an interest rate. The terminology just changes depending on what application you're trying to perform. So when people are performing present value calculations, they'll generally refer to the interest rate as a discount rate, as you're discounting back in time. But when dealing with future value calculations, people will usually refer to the interest rate as a rate of return or a required rate of return that they would like to achieve. And that's because they're then growing their present value forward into the future. Unlike what we just did here, where we returned our future value back to the present by discounting it back. So now when looking to solve for future value, using the bottom timeline here, just reversing what we did up above, you now apply the 10% rate of return to our $100 to achieve a future value of $110. And again, you're just reversing what we've done up above. You're now going to multiply our 100 by 1.1, which is growing it forward by 10% to allow us to achieve the future value of $110. Now, the formula for working out present value of a single cash flow is quite simple, and I've got it just here. So it's PV, which is present value, is equal to FV divided by 1 plus R to the power of N, and that's in parentheses. Now, FV stands for future value. I'm sure everybody knows that. R equals the interest rate, discount rate, or the required rate of return. And N is the number of compounding periods. Now, to get started using the formula, we're going to take off with one simple example using a yearly compounding frequency. Now, that's going to be quite simple, and it's just to get your head wrapped around it, just to understand it. And then once we've passed that, we're going to do another 2 more examples. The first one using a semi-annual compounding frequency, and then the last example will be using a daily compounding frequency. All right, now here's the question that we've got. So we want to solve for present value. What is the present value of a $10,000 cash flow in 10 years from now, given an 8% interest rate compounded annually, or our discount rate, or our required rate of return? So the formula here is present value equals future value divided by 1 plus R to the power of N in parentheses. Now, we just went through that. But what I've got over here for you is I've just placed the values on the screen, just in case you need a bit of extra hand, especially during this first example. So our FV, our future value, is our $10,000 cash flow that we're going to receive in the future. R, our interest rate, is 8%. Now, like you probably already know, to use any percentage in an equation, you need to convert it to decimal form. So divide your 8% by 100, and you'll get a decimal value of 0.08. And N, our compounding periods, is 10. That's our 10 years of compounding growth. All right, now that we've got all our values here, we can put it into the formula and come up with a present value. So PV is equal to FV, which is our $10,000. And we're going to now divide that by 1 plus R to the power of N. So 1 plus R, which is our decimal value of 0.08, close the bracket, and our N compounding period is our 10. Now if you compute this through your calculator, you will get to a present value today of $4,631.93. And I hope that was pretty straightforward. Give it a try and see what you come up with as well. All right, now before we jump into the next two examples, I just want to let you know that they're going to be using a compounding frequency other than annual. So we have to also work out now its effective annual rate before we can tackle any of the questions. Now, if you already know what the EAR is, the effective annual rate is, that's great. If you've come from my previous video, you already have a good understanding on it. But if you haven't seen my previous video on future value of a single cash flow, which I've just linked up above again, I really recommend going back and watching it. Now if you don't want to watch the whole video, that's fine. Just start it from 4 minutes and 5 seconds in, and that's where I really go in depth on the EAR. But I'm just going to quickly touch on its formula again. So the EAR is equal to 1 plus the periodic rate to the power of N compounding periods in parentheses, and then minus 1. So the periodic rate is the stated annual rate divided by the number of compounding periods, and N is the number of compounding periods, sorry, N. All right, now let's jump into the example. All right, now for this example, what we're going to try to do is solve to find present value of a $120,000 cash flow that we're set to receive in 5 years from now. And we're going to be using an interest rate of 6% compounded semi-annually. So there's 2 compounding periods in 1 year. So the first thing we have to do before solving for present value is work out the EAR, like we just previously discussed, and that will then give us a value which we can use for our present value calculation, which we're going to do just after this. So firstly, I've got the formula for EAR on the board. EAR is equal to 1 plus the periodic rate divided, to the power of N, and that's in parentheses, minus 1. Now, to get our periodic rate, I've just put it over here. I've already done it for you. To do that, all I did was I divided our 6% by 2, which is the 2 compounding periods in 1 year when talking semi-annually, and that gives you 3%. Now, like always, we can't use our percentage in the equation, so we need to convert it into decimal form. So therefore, 3 divided by 100 will give us a decimal value of 0.03. So now we can go forward and use the formula. So EAR is equal now to 1 plus our periodic rate, which is 0.03, and our N compounding periods is 2. So our semi-annually, 2 minus 1. And if you input that into the calculator, you're going to get an EAR of 0.0609. And if you want to, you can multiply this by 100, just to show you exactly what the interest rate is as a percentage, and you'll see that the EAR is an interest rate of 6.09%. So that's the effective annual rate of interest that you're actually going to receive over the year. But the financial institution has listed it as 6% compounded semi-annually. Alright guys, now that we've got our EAR sorted, we can now go forward and solve the question of our present value of the $120,000. So I've just listed here the EAR is 6.09%. The decimal value that we're going to be using though is 0.0609. So the formula again is on the board. PV is equal to FV, future value, divided by 1 plus R to the power of N in parentheses. So pretty straightforward. We're just going to fill all the blanks in and get a present value calculation answer. So PV is equal to FV, which is our $120,000, divided by 1 plus R to the power of N, which is 1 plus R, which is our 0.069 as a decimal, 09, sorry, to the power of N, which is our 5 compounding periods. And if you punch all that through the calculator, you're going to get a present value of $89,291.27. Now I hope this was simple enough for you to grasp, and now in the next example that we're going to be using, it's going to be going through with a daily compounding frequency, and that way you're going to get a good variation of compounding frequencies between this video and my last video. Now guys, if you're getting value for this content, please smash that like button, consider subscribing, and that way I really know that you're getting value from my content, and it keeps me going, pushing me to keep making videos. Okay, now for the third example, the question we have, again solving for present value, is what is the present value of a $50,000 cash flow that we're going to be receiving in 4 years' time, and the interest rate we're now going to work with is a 5% interest rate compounded daily. So it's 365 compounding periods in 1 year. So first things first, before going to find the present value, we need to compute the EAR, and to do this we need our periodic rate, which I've actually just worked out for you again, just to the side to make things a little bit quicker. So what you need to do is divide your interest rate, which is 5%, by the 365 compounding periods in the 1 year, which will give you a decimal, or it will give you a percentage of 0.013698 as a percentage. Sorry, I should clarify that. But you now want to convert that percentage, even though it is already a decimal because it's so small, into a proper decimal value by dividing it by 100. And you're going to get this small number down here, which is 0.001369. And that's our periodic rate as a decimal value, which we can use up here in the formula. So now we can solve for EAR, the effective annual rate, by filling in our values. So it's now 1 plus this very small number down here. Sorry if I miss a few zeros when I say it. 0.00139 to the power of 365 compounding periods. So 365. I'm getting a bit close over here, minus 1. Sorry about that, but I'm sure you can still see what's going on. So if you put this value through the calculator and get an answer for that, you'll get a decimal of 0.051234. Now, look, normally I don't carry out decimals this far, but just because I want you guys to get a similar value if you do decide to push this all through the calculator. So that's why I'm carrying so many decimal forward. But if you want to know this as an exact percentage, just multiply this number here by 100 and you have an EAR of 5.1234%. So 5% compounded daily is like saying you have 5.1234% compounded annually. Now that we've solved for the effective annual rate, we can go forward and finalize this example, working out the present value of the $50,000. So all we're going to do now is fill in the equation. So present value is equal to our future value of 50,000 divided by 1 plus r to the power of n again. I know I'm being a bit repetitive, but I just want to drum it in. So our r is our effective annual rate, which is here, this decimal value of 0.051234, to n, our compounding periods, which is 4 years, which is 4. And you should come to a final present value of $40,942. I hope that you guys now understand how to calculate the present value of a single cash flow. And like always, if you've got any questions, please feel free to ask them down below in the comments, and I'll do my best to get back to you as soon as possible. Now, please, if you've got any value, please consider hitting that like button, as it really helps support my channel. And now, guys, I'll see you in the next video where we start looking at the future value of an ordinary annuity, which is also known as the future value of a series of cash flows. And that's what I've got for you today, guys. Take care, and I'll see you in the next video. See ya.